Assalamualaikum warahmatullahi wabarakatuh. To my respected panel, Prof. Maya Dr. Syahrul Azmin bin Osman and TS Dr. Syahrin Hisham bin Aminuddin. My name is Ahmad Azma Afnan bin Mansur. I will present my final year project, which is Analysis and Experimental of Micro Gas Turbine Combustor. I have been supervised by Dr. Hamidun bin Saleh. Okay, for my introduction, due to development and industry growth fast in Malaysia, great improvement in mechanical and electrical work have been through. Micro gas turbine itself, if a rotation that will create a kinetic energy, then will be converted to a mechanical energy. A gas turbine, also being called as a combustion turbine. A gas turbine is one of the Malaysia popular electrical generator after the diesel generator. There are three main components in micro gas turbine, which is compressor, combustion chamber, and turbine. Compressor could bring a high pressure, so it called as an upstream rotation gas compressor. A combustion chamber will add a few gas, then ignition spark could lead to a combustor with a high temperature. The turbine that share a same shaft with a compressor will create a downstream force. Okay, next is left figure show a commercial gas turbine, and right figure is my combustion chamber that have been fabricated by me. Okay, next is a problem statement. The demand on electricity in Malaysia is increased due to the increasing of population and growth of industries. Gas turbine with a lower turbine inlet temperature will produce a poor output and decrease the efficiency. There are several methods to construct the gas turbine. One of them is create a combustor that can produce a high temperature outlet while producing a high pressure ratio. A high temperature output of combustor will capable to generating a high performance of gas turbine. Next is the objective of this product. The first objective is to determine the temperature that being combust in a combustor, and the second one is to study the flame pattern. Next is a scope of study. Scope of study is a temperature for run the combustion and relate to a gas flow rate. Second is the flame pattern produced in annular type combustor could be controlled. Next is literature review. Brice and Pau say that a combustion chamber is main component of a gas turbine engine. Scott somewhere say that the purpose of combustion engine is to transform a fuel chemical energy to a thermal energy. And P. Boy say that the gas turbine combustion chamber have three characteristics, which is a recirculation zone, a combustion zone, and a dilution zone. Kumar and Rao say the combustor must meet certain requirements in order to achieve a high efficiency. Aliza Kalantari say that if more combustion on a back of the engine, the blade of a turbine can easily be damaged. Okay. Siegfried and Evans say that there are three types of combustor. First is can type combustor, second is can annular type combustor, and third annular type combustor, which is my combustor. Next is methodology. This is my flowchart. We start with a problem statement, and at the end, the writing have been produced. This is summary of geometry design combustor that have been calculated using several equations and have been used to fabricate the combustor. This is a procedure to take the data. On a left figure, it is a panel and a battery. On a second figure, there is a flow meter, and a right figure, this is a thermal imaging camera. For a result, on a first experimental, for the second flow rate for a dual gas, temperature is 453.5 degrees Celsius. But for the single gas supply on 20 liter per minute flow rate, the temperature is 457.4, and they are a bit different, which is only 3.9 degrees Celsius. This show that the dual gas supply is more high performance than a single gas. Okay, on the flame pattern show on a dual gas supply is more highest when you can see on a white dot show that on a dual gas supply is more than a single gas supply. This is for my second experimental observation, which is using a preheat for 5 minutes on a combustor. The temperature for the 2 liter per minute for this single gas and dual gas supply show a big difference, which is 27.2 degrees Celsius. But on end of the experimental, the difference of the temperature only a bit. Say, okay, you can see on a flame pattern, which is the flame pattern for a single gas supply for a earlier experimental is bigger than a dual gas supply. But on end of the experimental, the flame pattern for dual gas supply on 20 liter per minute is more bigger than a single gas supply. Okay, this is analysis of temperature and flow rate for the first experimental. There are quite big uh, different. The dual gas supply have more highest temperature than a single gas supply. And this is for the second temperature analysis. You can see that on a single gas supply, for 2, 4, and 6 liter per minute, there are a significant increasing for the temperature. And for a dual gas supply, on 12 and 14 liter per minute, there are a same temperature have been recorded. Conclusion of my okay, the objective of this study have been achieved. Dual gas supply are more efficiency than a single gas supply. The preheat have a biggest amount than of the temperature than a non-preheat set. From the analysis, we can see that when the flow rate increase, the temperature also increase. Also the flame pattern. The flame pattern for dual gas is huger than a single gas supply. The maximum temperature have been captured in this experiment is 484 degrees Celsius. This value will increase if the micro gas turbine are completely function well. The flame pattern is greatest at the higher temperature value and also at the high flow rate. The preheat combustor give a major difference on early combustion, also at the end of the combustion. The recommendation. The combustion require more energy to get a perfect burning. Make a hole at the fuel injector to make a flame produce a blazing flame. Using an outside gas supply with a high pressure to make the fire being a more blazing flame. The preheat of a combustor to get the high performance of gas turbine. Change a flow meter to a digital flow meter to get more accuracy of flow rate. Last is sustainability. Sustainability itself is a focus on meeting the needs to present without compromising the ability of future generation to meet their needs. Okay, sustainability in micro gas turbine can reduce usage of electricity. Micro gas turbine doesn't produce any waste. Micro gas turbine also can reuse the heat using the heat exchanger. Micro gas turbine also easy to maintain because it only lubricant and the LPG. Okay, that's all. Thank you.